On March 28, 1979, a reactor in central Pennsylvania began to melt down. The cooling towers of 3 Mile Island became the national symbol of American energy anxiety, freezing the domestic nuclear industry for decades. 47 years later, those same cooling towers are being brought back to life. The funding isn't coming from the government or a traditional energy company. The plant is being resurrected by Microsoft through a 20-year exclusive contract to power artificial intelligence. Every time you query a large language model, the silicon executing that response generates severe heat. For every watt of power a data center spends on computing, it has to spend roughly another watt just to cool the servers down. Training a single frontier model requires 50 to 100 megawatts of continuous power, but the everyday math is even heavier. Running inference, the process of answering billions of user prompts day in and day out, consumes roughly 4.5 times more electricity than the initial training. In 2023, data centers used about 4% of the nation's total electricity. By 2030, artificial intelligence workloads are on track to push that share past 8%, doubling the load on an infrastructure that was never built to handle it. Solar farms and wind turbines cannot physically scale fast enough to plug this gap. To keep their models running, tech companies are bypassing the traditional grid and quietly locking up the country's legacy power plants. This diagram illustrates the energy trilemma. Hyperscale AI data centers need their power supply to meet 3 absolute constraints at once. The output must be massive, it must be reliable around the clock, and to meet corporate climate pledges, it must be completely carbon-free. Solar and wind generation hit the massive and carbon-free targets, but they fail on reliability. A frontier model cannot tolerate an interruption when the wind dies down. A sudden power loss can wipe out weeks of computation, costing tens of millions of dollars. AI requires 99.99% uptime. Coal and natural gas provide the massive scale and the reliability, but they fail the carbon constraint. Microsoft, Google, and Amazon have all made legally binding multi-decade carbon neutrality commitments that they cannot afford to break. Pick any 2 requirements and the market is full of options. Pick all 3, and the only existing technology capable of solving the equation is nuclear power. Silicon Valley is now driving the largest revival of atomic energy in 50 years. What began as an engineering constraint has turned into a bidding war. The world's wealthiest companies are aggressively competing to buy up every megawatt of clean baseload power they can find. Amazon Web Services spent $650 million to siphon power directly from the Susquehanna nuclear plant in Pennsylvania. That single facility will draw enough electricity to run a mid-sized city. In Wyoming, Bill Gates personally invested $1 billion into TerraPower, a next-generation nuclear facility that he explicitly confirmed will fuel both homes and artificial intelligence data centers. Then there is Stargate, a $100 billion joint venture to build the largest AI data center complex ever attempted. The developers are building their own dedicated energy infrastructure from scratch because no existing utility can match the speed they require. These hyperscalers are structurally outbidding ordinary utilities. They are targeting existing reactors and signing exclusive agreements to lock up 100% of a plant's output for decades. This removes critical power generation from the open market. A handful of megacorporations are effectively privatizing large segments of the public electrical grid for their exclusive use. When tech giants remove a nuclear plant's capacity from the public pool, homes and hospitals have to compete for a shrinking supply of electricity. In regions like the PJM interconnection, which serves Pennsylvania, this shrinking supply has already driven capacity prices to record highs. The physical environment absorbs a massive hit as well. A nuclear plant the size of 3 Mile Island requires millions of gallons of water per day for cooling. So do the data centers it powers. When a region hosts both, river levels drop and agricultural users find themselves competing with tech firms for local water. Then there is the waste. The United States has not opened a long-term nuclear repository in decades. Reviving old reactors means generating more spent fuel, which is indefinitely housed on site in dry casks without a permanent disposal solution. Microsoft, Amazon, and Google will extract immense, concentrated profits from the artificial intelligence products running in these facilities. Meanwhile, the higher utility bills, the depleted water tables, and the nuclear waste are diffused across local citizens. This technology is producing highly valuable tools. Artificial intelligence is accelerating drug discovery, organizing complex data, and advancing scientific research at an incredible pace. But we are committing hundreds of billions of dollars to restructure the energy grid of the developed world for a single private industry. The people absorbing the environmental and financial externalities were never asked if they agreed to the terms. The technology simply moved faster than our regulatory systems could process. Without a public vote or a national debate, ordinary citizens have been drafted to unknowingly subsidize the AI revolution.